Okay, let's just jump right into something that, honestly, sounds completely impossible. The idea is you take a standard diesel generator, you hook up a big battery to it, and suddenly you're cutting its fuel use by like half. But here's the thing, all the electricity is still coming from that same generator burning diesel, so how does that even work? To help me wrap my head around this, we've got an expert, Blue, with us. Welcome to the show.
Thanks for having me. It's a great question to start with.
Right, let's just put the core problem on the table. How can this possibly save fuel? To me, the battery is just a middleman, you know? You burn diesel to make power, you lose a little energy storing it in the battery, you lose a little more taking it out. It feels like it should actually use more fuel. It seems to go against the basic law of conservation of energy. So, Blue, what are we all missing here?
That is the perfect way to frame it. And you are 100% right. You can't create energy from nothing. The secret isn't about creating energy, it's all about efficiency. See, while the total amount of energy is conserved, the efficiency of a diesel engine is, well, it's all over the place. And that's the loophole. That's what we're going to exploit.
Okay, so let's put this to the test with some real numbers. Get away from the theory. We're going to take a totally standard 100 kVA generator. You see these things everywhere. And our goal is simple. We need to produce exactly 100 kilowatt hours of electricity. But we're going to do it in 3 totally different ways. And just watch how much fuel it actually burns each time. All right, scenario number 1. Let's call this the golden zone. This is the sweet spot. This is where the generator is happiest, running at about 70% of its maximum power. The best analogy is a big truck on a long, flat highway. Just cruising. It's what the engine was literally built to do.
So in this perfect ideal world, making our 100 kilowatt hours of power burns exactly 27.5 liters of fuel, okay? Remember that number. That's our benchmark. That's the absolute best this machine can possibly do.
Okay, that makes sense. But what happens when you have a really low power demand? Say, I'm just running a couple of lights, using maybe 10% of what the generator can do. I mean, my assumption would be that's got to use way less fuel, right? And that's the logical assumption. And it's exactly where the efficiency trap is. We call this the waste zone. Think of it this way. It's like using a massive SUV with a giant engine just to drive one block in stop-and-go traffic. You just know you're burning an absurd amount of gas for almost no reason.
To produce that same 100 kilowatt hours of useful electricity, but at only 10% load, that generator will burn a shocking 60 liters of fuel.
60 liters?
Wait a second. Look at the chart. It's right there. That is more than double the fuel to do the exact same amount of work.
How is that even possible? It's wild, right? And that's the absolute core of the problem. A massive chunk of your fuel is just wasted overcoming the internal friction of that big engine, just keeping the heavy metal parts spinning. At low loads, most of your diesel is just making heat and noise, not useful electricity.
So now let's get to our third scenario, the real world. Because on a construction site or at an event, the power load is, well, it's chaotic. It's like an EKG reading. You have long periods of almost no power demand, and then bam, a sudden massive spike when a heavy tool, like a crane or a welder, kicks in. The generator has to be running 24/7 to handle those peaks, but its average load throughout the day is often only around 20%. And in this much more realistic day-to-day scenario, making our 100 kilowatt hours takes 50 liters of fuel. 50. It's still nearly double what it should be. And this is how most generators in the world are operating, every single day.
Okay, hold on. I think the light bulb is starting to go on here. So the real magic of the hybrid system, its job isn't to create energy, it's to stop the generator from ever running in those horrible, inefficient waste zones. Is that it? You got it. The logic is incredibly simple, but it's really powerful. So, step 1, whenever the worksite needs just a little bit of power, the generator just turns completely off. Done. The battery handles everything silently, you're wasting 0 fuel. Then, step 2, when the battery needs a recharge, the generator fires up, and we force it to run hard, right in that high-efficiency golden zone. It produces a ton of power, enough to run the site and use all that extra juice to rapidly charge the battery back up. Oh, okay, I totally get it now. That's the aha moment right there. You're not breaking any laws of physics. You're just taking all that fuel that would have been wasted just idling the engine at low load, and you're converting that idle fuel waste into useful electricity and then just storing it in the battery for when you need it. That's a perfect way to put it. We use the battery as a buffer. It absorbs all those chaotic ups and downs in power demand. This lets us completely get rid of all that wasteful low-load runtime and replace it with these short, smart bursts of highly efficient high-load runtime. It's just about optimizing when and how that engine does its job.
And here's where it gets really exciting. The savings, they don't stop at the fuel tank. Because once you stop running an engine inefficiently for 24 hours a day, all these other amazing benefits just start to pop up.
Oh, the benefits are huge. First off, maintenance costs just plummet. An engine that only runs 4 to 6 hours a day might need service once a year, instead of 4 times. Second, you completely eliminate a nasty problem called wet stacking. That's a carbon buildup in the engine from low-load operation that can seriously shorten its life. And of course, for 18 to 20 hours a day, the site is running on completely silent battery power. For the people working there, that's an absolute game changer.
So it all comes back to this. This was never about some kind of magic or breaking the laws of physics. It was just about finding a much, much smarter way to work, a way that eliminates this colossal amount of hidden energy waste that we've all just kind of accepted as normal.
Blue, that was fantastic. You've completely cleared this up. The secret isn't magic, it's just being smart about waste. And you know, that point you made about silent power, it leaves us with one last question to chew on. Why is silence also a form of productivity? We'll have to dig into that one next time. Thanks for watching.